For exercise 2.7, I've actually just gone ahead and done all the working that's required before drawing the graph, just to save a bit of time, because I think we've done enough of it already so that you get the idea of how that works. So exercise 2.7 says, sketch the rational function y equals, well, 2x plus 5 times x plus 4 divided by x squared plus x plus 5, and you can expand out the top part to get that, and making the key features clear. So, well, first up, to find the maximum and minimum, you have to differentiate and set equal to 0, and it turns out that that happens when x is equal to 1.31 or negative 3.13. And because of the structure of this rational function, we can clearly see that if x is negative, we're going to get a, well, if there is a negative output for one of these two, then it has to belong to the negative number here, because anything positive is going to give a positive output. And that's what ends up happening when we calculate the range. So there's all the working for the range in green. It turns out that the range is between negative 0.093 and 5.04. So clearly the negative 0.093 goes with the x value of negative 3.13, and the 5.04 goes with the x value of 1.31. So there's some of the working for that. I guess when you do it in your exam, you don't have to be so detailed, like you don't have to draw this lame little parabola if you don't want to, but it's up to you. And finally, just calculating whether there's an interception with the horizontal asymptote, which is clearly y equals 2, because 2 divided by 1 is 2. And we find out that it intercepts with the horizontal asymptote when x is equal to negative 10 over 11. And then lastly, just compiling all this information here, we are ready to draw the graph. So let's go ahead and mark all these points on the graph. So we have x-intercepts when x is equal to negative 4 or negative 5 over 2, so negative 2.5. So let's say this is 1, 2, 3, 4. So negative 2.5 would be here, and then negative 4 is here. So those are our two x-intercepts. And we have a y-intercept at y equals 4. So 1, 2, 3, 4. So that's our y-intercept. We have no vertical asymptotes. We have the horizontal asymptote y equals 2. So we can go ahead and mark that on there. Y equals 2. And we have our maximum point when x is equal to 1.31 and y is equal to 5.04. So here can be 5. So here is 1. Here is 2. So the maximum point is going to be about here. And then you can make it clear by saying 1.31 and 5.04. So that's our maximum. And then the minimum is when x is negative 3.13, negative 1, negative 2, negative 3, so about here. And the y coordinate is negative 0.09. So our minimum point is going to be about there. Can make it clear what is the values of that. Negative 3.13 and negative 0.093. Okay, and then, well, I think we're pretty much, there's one more key detail. It intercepts with the horizontal asymptote when x is equal to negative 10 over 11, so about there, just under 1. Okay, let me just make it clear what point that is. Negative 10 over 11 and 2. And I guess I should label the intercepts as well. So this is 4, This one is -4, and this one is -2.5. Alright, we are ready to draw it now. So in the working, when we set the derivative equal to 0, we found there's only two stationary points, one here and one here, so it can't turn anywhere else. It needs to tend towards the line y equals 2, as x tends to infinity or negative infinity, and it needs to pass through these points, so it forces the shape of the graph to look like this. And then it just gets closer and closer to y equals 2. So, that's our graph.